Hello, this is Jack Jackson. This video starts a playlist in which we will talk about sequences and series. This is usually part of a Calculus 2 class. In fact, it's my Unit 3 in Calculus 2 or Unit 10 in Calculus in general for me. So it'll be the 10th of these playlists. And you can kind of see there very quickly some of the preliminary table of contents. But let's talk about an introduction to the topic in these notes. So before we do that, let's give a quick overview and review, and let's look back, taking a brief look back where we've been. So these notes by me for units 1 through 9, the corresponding calculus playlist 1 through 9 from the earlier playlist on my YouTube channel, calculus section. They comprise the content of Calculus 1 and the first half of Calculus 2. In them, we first introduced the concept of a limit. Either on stage or behind the scenes, everything in calculus is based upon taking a limit of some pre-calculus concept. We start by applying these limits to real valued functions of a real variable, functions where both the inputs and outputs are subsets of the real numbers. And next, we introduce the two main concepts of calculus, derivatives and definite integrals. In Calculus 1 portion of these notes and videos, we alternated between derivatives and integrals. Each of the following units corresponds to a set of notes in a playlist on my YouTube channel. Presumably, you've already worked through these. Unit 1, we introduced limits formally and informally and reviewed some pre-calculus, particularly remembering characteristics of several real-valued functions of a real variable. In Unit 2, we had a unit introducing the basic concepts, interpretations, and approximations of the derivative, seeing that the derivative is a limit applied to a slope or rate of change. In Unit 3, we followed Unit 2 by a similar unit for the definite integral, where we saw a definite integral as a limit applied to an accumulation of area. At the end of Unit 3, we studied the fundamental theorem of calculus, which explains an inverse relationship between derivatives and definite integrals. In Unit 4, we derived and used algebraic shortcut rules for finding the formula for the derivative function given the formula of the original function. In Unit 5, we next learned to reverse these derivative shortcuts to be able to find antiderivative formulas and use them to evaluate definite integrals, at least for the easier cases. In Unit 6, we applied differential calculus to solve several problems in a variety of real-world scenarios, particularly including related rate and optimization problems in a variety of contexts. In Unit 7, we first saw some applications of integral calculus, which we used to solve several problems in a variety of real-world scenarios. In particular, I included business applications, which are typically studied in a business calculus course. Units 1 through 7 make up Calculus 1. I have a playlist called Calculus 1 Review, which is where we started Calculus 2 with a quick review of the basic ideas and core concepts from Calculus 1, Units 1 through 7, where I started with a quick, around 90-minute review of integral derivative differential calculus and integral calculus, about 90-ish minutes on each, and then follow that up by going over the review problems at the end of the other units, which are actually also in the other playlists. Those are duplicated. Next, we move to Unit 8, which picked up where Unit 5 left off. So really, it's kind of a continuation of Unit 5. We learn more advanced techniques for finding antiderivatives and applying them to definite integral calculations. So the notes for Unit 5 and 8 made up Unit 1 in Calculus 2. And likewise in Unit 9, it picked up where Unit 7 left off and where we learned further applications of definite integrals. So the notes for Units 7 and 9 comprised Unit 2 in my Calculus 2 course. So therefore, at this point, we have introduced limits, derivatives, and integrals. We've explored their definitions, interpretations, approximations, algebraic manipulations, and applications of these concepts. And all of this has been done in the context of the further study of functions. So far, our functions have all been real-valued functions of a real variable. In other words, they have been functions where the input and output are both some subset of the real numbers, typically with intervals of real values included in both the input and the output. So now where do we go from here? So the entire rest of Calculus 2 and all of Calculus 3 may be viewed as primarily taking the basic concepts of calculus learned thus far and applying them to functions of different types. During Calculus 2 and 3, we will ultimately study functions of all of the following types, and we will apply calculus concepts to each of them. Sequences are a type of function where the input is a natural number and the output is a real number. Multivariable functions are functions where we have ordered pairs of real numbers and outputs are real numbers, or perhaps ordered triples of real numbers and then outputs are real numbers, or ordered n-tuples of real numbers and outputs are real numbers. So those would be graphs of where the points, instead of being graphed in a plane, are in three-dimensional space, 4, 5, 6, 7-dimensional space, whatever. We can have 2D parametric functions where the input is a single real number, but the output is an ordered pair of real numbers. Or 3D parametric functions where the input is a real number and the output's an ordered triple of real numbers. And then we have several kinds of vector functions. We have functions where the input's a vector and the output's a real number, also known as a scalar. We have inputs where real number scalars are inputs and outputs are vectors. And we also have functions where the input and output are both vectors. So a lot of that is going to be put off until Calculus 3, but right now we're going to focus on the first line of this table, sequences. So in this unit, this playlist, we will be focusing on the first type of function above, sequences. Since they are discrete functions, there's really not much calculus that can be applied specifically to sequences. Basically, we'll only be finding limits of infinite sequences. But it also has a related topic called series. And one thing we can do is we can talk about the sum of a sequence. The sum of a sequence is called a series. Most of our work on this unit will be with infinite series. The main question that will concern us is if an infinite series converges to limit or if it diverges, fails to have a limit. We will develop and apply several tests to answer this question. This portion of the unit will be much like when we learn the factoring of polynomials or techniques of integration. In those topics, what do we have? We were able to examine a structure of a given object and then choose from a list of different techniques and find the one appropriate for the problem and apply it. Whether that was trying to decide whether it was factoring as a difference of two squares or a sum of two cubes, or whether that was integration by parts or integration by partial fraction decomposition. Similarly, we will learn to examine the structure of an infinite series, and we will determine a bunch of tests that we can use, and we'll be able to determine which of these tests should be applied to determine if it converges or not. After studying the convergence of series of constants, we will examine Taylor series. Taylor series allow us to approximate a function locally with a polynomial function. This is an extension of the idea of approximating a function locally with its tangent line. Next, we'll extend the idea of a polynomial to a polynomial with infinitely many terms, which is a power series. Power series then give us an alternate way of representing functions, at least where they converge. The idea of a power series representation is the only really one truly big idea that's completely new studied in Calculus 2. The rest of Calculus 2 can easily be viewed as extensions of the basic ideas in Calculus 1. Not that there's not a lot of new stuff and good stuff, But as far as a huge idea, really this one power series is it. And in the next video, we'll jump right in and start talking about sequences.